The Kepler Space Telescope was built with a single mission in mind: stare deep into one tiny patch of the Milky Way and hunt for new worlds. Over its lifetime, this dedicated exoplanet hunter watched hundreds of thousands of stars, searching for the faintest dips in their light. The result? A cosmic treasure haul, thousands of confirmed exoplanets, and an entirely new understanding of how common alien worlds really are. In 2009, a Delta II rocket carried NASA's Kepler Space Telescope into orbit, an observatory built for one purpose: to stare at a single patch of the Milky Way and uncover alien worlds. As part of NASA's Discovery program, Kepler carried the largest primary mirror ever sent into deep space at the time, paired with a 96-megapixel photometer sensitive enough to detect the slightest dip in starlight, like noticing a moth drift across a stadium spotlight. That tiny flicker meant a planet. Astronomers hoped Kepler would answer two big questions: how many stars have planets, and how many of those worlds might be capable of hosting life. Over 9 years, Kepler observed more than 500,000 stars and confirmed 2,662 exoplanets, worlds unlike anything in our solar system. It found super-Earths, hot Jupiters, molten planets with day sides hot enough to melt iron, and giant worlds orbiting twin suns that deliver real-life binary sunsets. But Kepler's greatest legacy was finding Earth-sized planets in the Goldilocks zone, the region where liquid water could exist. Among the most exciting discoveries was K218b, where two research teams in 2019 detected signs of water vapor in its atmosphere, the first time Kepler data revealed water on a habitable zone world. This mini-Neptune, 8 times Earth's mass, orbits a red dwarf 124 light-years away. Kepler's statistics suggest about 6% of red dwarfs have Earth-sized planets in their habitable zones, meaning our galaxy could host billions of potentially life-friendly worlds. It also uncovered Kepler-186f, the first Earth-sized planet in a habitable zone, later found to likely have seasons and a stable tilt, and Kepler-1649c, nearly identical to Earth in size and temperature, and rediscovered in 2020 after being buried in old data. Yet only 16 of Kepler's 2,662 confirmed exoplanets sit in the habitable zone, and many face harsh conditions: tidal locking, thick hydrogen atmospheres, strong ultraviolet radiation, or extreme temperatures from -100 degrees Celsius to +47 degrees Celsius. Humanity doesn't yet have the tools to fully study their atmospheres. Most of Kepler's discoveries are far stranger, but scientifically invaluable gas giants skimming their stars and days-long orbits, super-Earths made of rock or gas, lava worlds with oceans of molten rock, Thonian planets that are the stripped cores of hot Jupiters, and possible Trojan planets sharing orbits with larger worlds. One standout is KOI5a, first spotted in 2009, but lost in the data until tests confirmed it a decade later. It orbits inside a 3-star system, offering rare insight into how planets form in chaotic environments. Kepler was retired on October 30, 2018 after running out of fuel, a moment that coincidentally fell on the anniversary of Johannes Kepler's death. But its mission continues through its enormous data archive, still revealing new planets as scientists pair its findings with newer observatories like TESS, Hubble, and Spitzer. Its legacy will soon be expanded by the James Webb Space Telescope, which is designed to study these alien worlds in unprecedented detail. Kepler ultimately revealed something profound. Roughly 1 in 5 Sun-like stars may host an Earth Earth-sized planet at the right temperature for life. In a galaxy with hundreds of billions of stars, that means billions of potential Earth-like worlds. Kepler didn't just discover planets. It transformed our understanding of the cosmos and brought us closer than ever to answering the question humanity has asked for centuries. Are we alone?